Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video on primes, factors, and multiples. So let's start with a number like 12. So what we're going to first do is find the factors of 12. So the factors of a number, I'm going to check every number less than or equal to 12. A number more than 12 can't be a factor of 12. So I'm going to check each of these numbers to see whether or not it's a factor of 12. So if it's a factor of 12, it means it goes into 12 evenly. So 1 is a factor of any whole number because 1 always goes evenly into 12. 12 divided by 1 gives you a whole number, 12. So 1 is a factor. So factors always come in pairs. 1 and 12 are both factors of 12 because 1 times 12 equals 12. 2 goes into 12 evenly. 2 times 6 is equal to 12. So both of them are factors. If you divide 12 by 2, you get 6, a whole number. If you divide 12 by 6, you get 2, a whole number. So they are factors. So similarly, 3 and 4 are factors. They both multiply to give 12. 5, however, is not a factor of 12. So the reason for that, if you divide 12 by 5, you don't get a whole number. You get 2.4. 5 does not go evenly into 12, and that's the case for 7, 8, 9, 10, and 11. None of those numbers go into 12 evenly. If you divide 12 by 7 or 12 by 8, you won't get a whole number. So they are not factors of 12. So the factors of 12 are 1, 2, 3, 4, 6, and 12. So make sure you don't mix up factors with multiples. So the multiples of a number are just all the numbers divisible by that number. So the multiples of 12 include every number divisible by 12. So 12 is divisible by 12. 24 is divisible by 12. We're counting up by 12s. All of these numbers I'm writing, they are multiples of 12 because if you divide them by 12, then you get a whole number. So there are infinitely many multiples of 12. I could keep going. 84, 96, they keep going on forever. So all of these numbers, 12, 24, 36, and so on, they are all multiples of 12 because when you divide them by 12, you get a whole number. Another way to look at it is all the multiples of 12 are numbers for which 12 is a factor. So 12 is a factor of 12. 12 is a factor of 24, so 24 is a multiple. 12 is a factor of 36, so 36 is a multiple of 12. So I'll explain in this diagram here. If the smaller number is a factor of the larger number, so 12 is a factor of 36, because 36 divided by 12 is a whole number, then that means that 36 is a multiple of 12. So if the smaller number is a factor, the larger number is a multiple. So that's the relationships between factors and multiples. So some numbers are special and they don't have many factors at all. So I said before that any number greater than 1 has at least 2 factors, itself and 1. If they are the only factors, we say the number is prime. So prime numbers are numbers with only 2 factors, themselves and 1. So primes are very important. They're like the building blocks of numbers, just like amino acids are the building blocks of proteins. So let's look at a number like 27. So 27 has factors 1, 27, but it's also divisible by 3 and 9. 3 and 9 are factors. So 27 is not a prime. If a number's not a prime, we call it a composite. So what would be an example of a prime? So numbers like 5, 11, 23, 47, 97, all of these numbers here, they are prime numbers. Their only factors are themselves and 1. The only factors are 5 and 1. 11, its only factors are 11 and 1. There are no other whole numbers that you can multiply to get 11. So that's why these numbers are prime. So the same is true for 23, 47, and 97. They are also prime numbers because their only factors are themselves and 1. Now, there are heaps more prime numbers. In fact, there are infinitely many prime numbers. I just listed a few there. So it's really cool. It turns out that you can write any number, any whole number, as the product of primes. So that's what we're going to look at on the next slide. So in order to write a whole number as the product of primes, we use what are called prime factor trees. So I'm going to pick two random numbers. I'll pick 70 and 72. I'm going to write these as the product of primes. So let's look at 70. 70 is not a prime number. It's divisible by 10, by 7, by 5, by 14. It has factors other than itself and 1. So in order to write it as the product of primes, I can just find any two numbers that multiply by 70 as long as neither number's 1. So 70 is 10 times 7. So note here, we're timesing. So 7 is an example of a prime number. Its only factors are 7 and 1. So what we do is we stop here with 7. We leave it as it is. 10, however, is composite. It is not a prime number. So what we do is we're going to write 10 as the product of two prime numbers. So 10 you can write as 5 times 2. So 70 is 5 times 2 times 7. That's writing 70 as the product of primes. Note, product means times, and all of these numbers are prime. So let's do the same for 72. So we just need to find any two factors of 72. So I could pick, 18 and 4. I could pick, say, 36 and 2. So 2 is a prime number. I stop there. So 36 is not prime. It has factors other than itself and 1. So I've just got to pick 2. So I'll pick 4 and 9. 4 times 9 is 36. Now, 4 is not a prime number, but I can write it as 2 times 2. 9 is not a prime number, but I can write it as 3 times 3. So for 72, I've written it as 2 times 2 times 3 times 3 times 2. So it might be easier to write this in a shorter way. 2 times 2 times 2 is the same as 2 to the power of 3. And then 3 times 3 is 3 to the power of 2. So I've written 72 as heaps of prime numbers multiplied together. 2 and 3 are prime numbers. So I want you to note you always get the same answer regardless of the factors you start with. So for this one here, I would have got the same factor if I wrote, say, 14 times 5. For 72, I still would have got this answer if I had written it, say, as 18 times 4 or 9 times 8. You still get exactly the same answer. So prime factor trees are very helpful. It turns out they can help us find highest common factor and lowest common multiple. And that's what we're going to do now. So remember that factor of a number is something that goes in to that number. So if I have two numbers like 12 and 15, I can find the highest number that goes into 12 that also goes into 15. So 12 and 15 would also have a lowest common multiple. That's the lowest number that's divisible by 12, but also divisible by 15. So how could you figure that out? So let's say I'm looking at 12 and 15. What I could do is list the factors of both numbers. So previously, I found that the factors of 12 were 1, 2, 3, 4, 6, and 12. So for 15, its factors are 1, 3, 5, and 15. So the highest common factor is the highest number that appears in both lists. So that number there is 3. 3 is the highest number that goes into 12, but also 15. So I can write highest common factor of 12 and 15 is equal to 3. So now let's look at multiples. Well, there's infinitely many multiples, but I can just write a few. So multiples of 12. I went 12, 24, 36, 48, 60, 72, 84, and so on. So multiples of 15. So the lowest is 15, then we count up by 15s, and we keep going. So what we're doing when we're finding the lowest common multiple is finding the lowest number in each list. And hopefully you see that is 60. So the lowest common multiple of 12 and 15 is 60. But there's a problem with using this method. What if a number has heaps of factors? It would take forever to find the highest common factor. What if the multiple, the lowest common multiple of two numbers, is a massive number like 720? That again will take you forever. So a definitive way to do this quicker, we could use factor trees. So let's start by doing a factor tree for 12. So it has factors of 4 and 3. Again, it doesn't matter which factors I choose as long as I don't choose one. I'll get the same answer. So 4 is composite, so I can write it as 2 times 2. So 12 is 2 times 2 times 3. Let's do the same for 15. So that's easy. It only has two prime factors, 5 and 3. So 15 is 5 times 3. So I've written 12 and 15 as the product of prime numbers. So how will that help me find the highest common factor? So when you've done this, the highest common factor is what's common in both prime factorizations. So C3 is common in both. That means the highest common factor is 3. So how do I find the lowest common multiple? Well, what I can do is I can multiply together everything, but I don't repeat things that are in both lists. So the lowest common multiple of 12 and 50, I've got 2 times 2 times 3. So I'm going to write all that. And then I have a 5 in the 15 list. So I'm going to also times by 5. I don't include this second 3 because I've already included the 3 over here. You don't repeat things that are in both lists. So the lowest common multiple is 2 times 2 times 3 times 5, which gives us our answer of 60. So there is a quicker way to finding lowest common multiple if that's a bit confusing. What you can do, and this works with any two numbers, really cool, the lowest common multiple of two numbers, A and B, what you can do is multiply them together and divide by their highest common factor. So for the lowest common multiple of 12 and 15, I can multiply them together and divide by 3, and I get the same answer of 60. So there's 3 ways that we can find the lowest common multiple. You can pick your favorite, but factor trees make it easier. So I'm going to do one more example with two larger numbers where we'll find their lowest common multiple and highest common factor. So let's say I have these two numbers, 48 and 84. So I am going to find their lowest common multiple and highest common factor by first using prime factor trees. So let's do 48. So you can pick any two factors of 48 as long as neither number's 1. So let's try 6 and 8. 6 is not a prime. I'm going to write it as 2 times 3. So 8 I can write as 4 times 2. So I'm not quite done yet. 2, 3, and 2, I've got primes. 4 is not a prime, so I need to factorize it further as 2 times 2. So I've figured out 48, if I write it as the product of primes, there is 1, 2, 3, 4 2s, 2 to the power of 4, 16 times 3. So let's do the same for 84. So any two numbers that go into 84 as long as neither of them is 1. So let's try 12 and 7. So 7 is a prime, because its only factors are 7 and 1. 12 is not a prime. It is divisible by, say, 6 and 2. So 6 is not a prime. I'll write it as 3 times 2. So 84, I've written as 2 times 2, 2 squared, times 3 times 7. Let's now use this to find the highest common factor and lowest common multiple of these two numbers. So to find the highest common factor, I just look for what is common in both trees. So I can see that both of them have 2 2s in the tree. They also have a 3. So note, I don't circle these 2 2s because this 84 only has 2 2s, so I can only circle 2 2s in the 48. So I multiply these together, and that gives me the highest common factor. So the highest common factor is 2 times 3 times 2, which is 12. 12 is the highest number that goes into 48 that also goes into 84. So let's now calculate the lowest common multiple of 48 and 84. So I multiply all of these numbers together that appear in the branches, but I don't repeat things twice. So what do I mean by that? So in 48, I have 2 times 3 times 2 times 2 times 2, right? Now, when I go to the 84, I don't include the 3, 2, and 2 because I've already circled them. They are common to both. You multiply everything together except you don't multiply things that are common more than once. So I'm not going to multiply by 3 again down here because 3 is common. I've already multiplied by 3. The only thing left to multiply by is 7. So this will be 2 times 3 times 2 times 2 times 2 times 7. So if I multiply together all of these numbers, I get 336. So 336 is the lowest number that's divisible by 48 and also by 84. 336 is 48 times 7 or 84 times 4. Now, I know that it's a bit hard to do this multiplication here, to know which ones to multiply and which ones not to include twice. I get that. So what you can do instead, if you don't understand this, you can use the easier method that I said. So what you do for the lowest common multiple of 48 and 84 is you multiply them together and then divide by their highest common factor of 12, because finding the highest common factor is easy. Now, if you're doing this without a calculator, you probably don't want to do 48 times 84. That takes a long time. So what we can do is cancel, which we did in a previous lesson. 12 goes into itself once, it goes into 48 4 times. 4 times 84, a lot easier to do. You get 336. We got the same answer from multiplying them together and dividing by the highest common factor as we did from multiplying together all the numbers in the prime factorization, but not multiplying those that are common. Okay, so you can use whichever method you like to get this number, this method or this method, doesn't matter. All right, thank you so much for tuning in. This has been the luckiest maths teacher in the world. Have a great day.